Okay, so let's take a look at problem 9. It says air is blown into a spherical balloon. The volume of the balloon is increasing at a rate of 6 cubic centimeters per second when the radius reaches 5 centimeters. How fast is its radius increasing? Okay, so we're looking at the rate of increase. So this is talking about a related rates problem. And it's referring to a sphere. So, and in particular the volume of the sphere. So what is the equation for volume of a sphere? It's V is equal to 4/3 pi r cubed. Okay, so in a related rates problem, before taking a look at any of the values, what we want to do is we want to take the equation and use implicit differentiation. So the derivative of v would be 1, but because it's implicit differentiation, I put the derivative, which is dv dt, and then I take the derivative of the right hand side, so the power rule for r cubed, so the 3 comes down times 4/3, and then pi, and then I decrease the power, so it becomes r squared. And then again, implicit differentiation means I write times dr dt. Okay, so so that's what we have. And now what values do we have? Right, so what is this 6 cubic centimeters per second? So that's the increase in the volume, the rate of increase in the volume, right? So it's a rate. So dv dt is equal to 6 cubic centimeters per second. What else do we have? We have the radius as being 5 centimeters. So r is equal to 5 centimeters. Okay, so that's the information we have. So we plug it into the equation now. Right, so 1 times 6 is equal to, and then here 3 times 4/3, just the 3 and the 3 cancels out, right? So we have 4 pi, r is 5, times dr dt. Okay, so so now I just solve for dr dt. Right, so this whole thing needs to be divided. So you get 1 times 6 is 6 over 4. What is 4 times 5 squared? 5 squared is 25, times 4 is 100, so that's 100 pi. Okay, so that's the calculation for dr dt. And if we calculate 6 divided by 100 pi, you should get 0.019. And then the units would be centimeters per second.